All right, so today we're going to be talking about bar graphs and dot plots. And we're going to talk about some terms. We discussed these yesterday in terms of the pulse rates. And we talked about maximum versus minimum range. Something we didn't discuss yet is frequency. So we'll be talking about that a little bit. And let's see if I can get this going here. So in your own words, you can define maximum value of a set of data. Damien? Good. So this is the biggest or the largest value in the data set. In the morning, the smart board is tired like we are, so I'm hoping the words will all of a sudden arrive. Okay. So the largest value in the data set is our maximum value. And then, Shirley?
The minimum value is just small.
And what's the definition of range? Or how would you find a range? Eva?
The maximum value minus the minimum.
Good. And then what I'm going to write is the range is just one number. It's the difference between these two numbers. So the maximum minus the minimum value. And do you guys remember what the range was for our heart rates yesterday? Brendan? So that was the one that we were comparing to. Yep. So it was 16. So that means the highest number, which was 88, minus the lowest number, which was 72, gave us a range of 16. So what do you think the range of ages of students in this school is? Like just the upper school. Damien?
I think it's a 13-year-old. So you'd say 5.
5. What do you guys think about that? A range of 5 in the upper school. Does that seem pretty accurate? Now, if you know the minimum, and Davey guessed that the minimum would be 13, we've always had a couple of 13-year-old freshmen, so that seems pretty reasonable. If you're given the range and the minimum, what can you find? Yeah, you can find the maximum value. But if you're just given the range, you don't know where that exists. So if I said the range of ages in a school is 5 years, you wouldn't know necessarily what the minimum or the maximum would be. If it was a high school, you could guess. But if you didn't know if it was a high school, what if it's an elementary school? What if it's a middle school? Okay. So the range gives you some piece of information, but not every piece of information. And in terms of statistics, how could you define frequency? So we had our data from yesterday, and do you remember what the most, the mode, we talked about the term mode yesterday, the pulse rate that occurred the most for us?
72.
Yeah, it was 72. Do you remember how many people had a pulse rate of 72 by any chance?
6.
6. Was it 6 or 7?
7.
Yeah, I guess it doesn't matter. But you would say the freak one, we could look at it. I have that back here. We'll see. Now I'm curious. But we could say that the frequency, let me look at Brendan's scatter plot. Brendan had 1, 2, 3, 4, 5, 6, 7 dots above 72. And I'll look at Talisa. 1, 2, 3, 4, 5, 6, 7. Okay. So 7 people had a pulse of 72. That means 72's frequency is 7. So frequency is the number of times data point occurs. So if I were to look at the data from our pulse, which I'm going to just grab real quick, I could create what's called a frequency table out of this. So a frequency table would have the pulse, because that's what we measured. So pulse, and then BPM. What do you think BPM stands for? Beats per minute, good. And then over here we'll have the frequency. This is called a frequency table. And 72 was our minimum value, and 72 occurred 7 times. So the frequency of that, or the number of times it came up, was 7 times. 76 came up 3 times. 80 came up twice. And then 84 came up twice. So that had a frequency of 2. And then 88 came up once. So frequency is the number of times the data points occur. So when you're finding, let's say, the average of these numbers, which we didn't have to do yesterday, but if you were, would you just add up 72 plus 76 plus 80 plus 84 and 88 and divide it by 5? Is that how we would find the average? Okay, how would we find the average then? David?
I would multiply the frequency by the plus and then add them up to it.
Okay, so why would you multiply the frequency by the pulse and then add them?
Because we find an average of everybody in the room, and we gotta count every single person.
Right. So there are 7 people that had a pulse of 72. So that's why you have to multiply 72 by 7 to count for every single person that had a pulse of 72. And then we have to add it to 3 times 76, because 3 people had a pulse of 76. And then 2 people had a pulse of 80. 2 people had a pulse of 84. Over. And then lastly, we had 1 person with a pulse of 88, so you could write 1 times 88 or just 88. So that would account for everyone, because this accounts for 7 people in the room, this accounts for 3 people in the room, 2 more people, 2 more people, and then 1 person. So this would be the sum of everybody's pulses. And then to find the average, what's another word for average? Mean. Mean. What is median? Because I've heard that yesterday and today. Davian? The middle number, okay? We take the sum of everything, and what do we divide by? Yeah, the number of people in this case, or the amount of data points. So how many would we divide by? 15. Good. And Maggie, how did you get 15? There is. And 15 also is the total of the frequency, right? Because each portion of frequency represents a person. So this would be the mean. And the layman's term for mean is just the average. And we're going to talk about that in later on this week in more depth. But that's where frequency comes up, because a lot of people who don't really understand frequency would just add these up and divide by 5. But if we did that, it would mean only 1 person had a pulse of 72, 1 person had a pulse of 76, and that there are only 5 people. Okay, so that's why frequency is so important. Right? Any questions on that? Great. All right. So you do have this information on your sheet. Bar graphs, we're going to contrast with something called histograms. So bar graphs, I know, are something you've been studying since like elementary school, but when you put them side by side with histograms, we can then talk about the differences. But today we're going to talk about bar graphs, and they're used to compare groups of data, and it's quick. and you can gather data into categories. So that's what bar graphs do. So we could create a bar graph of our pulse data if we created like different categories. Like maybe we had one bar graph or one bar that represented everyone who had a pulse in the 70s. That could be one bar. And then next to it, we could have another bar of everyone who had a pulse in the 80s. So you can really create a bar graph out of many, many different types of data. So the bar graph needs to have the following to be complete. You have to give a title. The X is the horizontal axis, the Y is vertical. And you have to label one of the X's with categories and the other one with amounts. So the number of people with that particular quality. Or we could do a bar graph of like, let's say, land masses. So if you're talking about like Asia, what's the land mass of Asia, or how many square miles does it take up? What's the land mass of Australia? All the different continents. The scaling has to be accurate. That means it has to go up by the same amount. So just because maybe one land mass is 50 square miles and another one is 1,000, you can't skip from 50 to 1,000 and then go up by 25x. It has to go up by a consistent amount. So that's what it means to have equal intervals. So this means it's like a number line. So every part, every little like mark on that axis, if it's this far apart, it represents 50 here. Then if you go to the next one, it has to be 50, 50, 50, regardless of what the data points are. So if you have a data point that's like, again, 50 square miles, that's a way of writing square miles, so you don't have to write out square, you just write miles squared. And then the next one is 1,000 square miles. And let's say the next one is 1,200 square miles. You can't go up by 950 here, and then here go up by 200 just because those are the data points. If these are the data points, I would probably start at 0, since the 50 is so close to 0. And you could go up by 500s, you could go up by 100s, 200s, but this has to be consistent. If I decide to go up by 200 square miles, this one is 400, this one is 600. Notice, well, they're roughly the same amount apart, okay? Even though I don't have any data points that are 200, 400, and 600, I have to put them up there because this has to be like a number line. It has to go up by equal intervals. So this first land mass would be 50, so it would be super small. So this would be, let's say, some data country like Oz. And then the next one would be 1,000 right up here, and then 1,200. So it would just go to where it's supposed to go. But this has to be independent of these, but it has to include all the values. So this axis has to go from 0 to beyond or to 1,200, so I can make sure to include all these values. So that's what you have to be careful of. So we have categories here. This is a farm example. They have these a lot in standardized tests. I don't know a lot about farms, so I like to throw them into our example. So, in case you don't either, you get familiar with them. So bushel is an amount of like a crop. And if I say it wrong, just let me know. So this crop, if it costs $1 per bushel, the demand, so that means the amount that's being bought from them, is 55 per week. At $2, if that's how much the crop costs per bushel or per amount, the demand was super high. It was 80 per week, and then you can see how it changes depending on the cost. So the height of the bar shows the amount of each category. Notice how these are equally scaled. They go up by 10 each time. And then you have these nice bars to show, well, if it costs $2 per bushel, we have the highest demand. So you'll do this in economics, which you'll take your junior year of high school, or upper school here, but you'll talk about demand versus price, or cost versus demand. And there's a sweet spot where, you know, if someone's deciding how much to charge, let's say for tennis shoes, okay, or like Jordans. Do they still sell Jordans? Okay. There's a sweet spot where if you make them too inexpensive, people will think they are cheap, like in quality, like they're not a quality item because they're too inexpensive. Like, you know, you go to the shoe store, the shoes are $10, you're gonna think a certain thing about that shoe because it costs so little. But you wanna sell your Jordans, so you can't make them too expensive where people don't have enough money to buy. So there's a sweet spot between demand, so how many are actually bought, and how much it costs. And looking at this, you can tell if you charge $2 per bushel, they're gonna have the most demand for that product. And everyone selling an item needs to find that sweet spot where they'll sell the most and make the most money. So that's where cost and demand come into play. And so bar graph is a good way to show that off. You can also flip the axes. This is also a very valid bar graph. Also, notice the bars don't touch. This is going to be different from the histogram, which we're going to talk about later on in the chapter. So this is how much area the different continents take up. And you guys probably know, looking at a map, that Australia is the smallest continent. You know, it doesn't even, it's just a little island. And they're in winter now. It's crazy. Their seasons are totally opposite ours. So Australia is our smallest continent, Asia is our largest continent, and that's really easy to tell from the graph. Could we tell the range from this graph?
Yeah.
So what pieces of information do I need to know to find the range?
The minimum.
Good. So who can tell me the maximum? Okay, Logan?
45. Just saying there.
Yeah, I'd say 45 million minus and minimum. Charlize? 9. So Australia, 90 million. What do you guys think about 90? You think 80? 90 or 80? Okay. So, I'm sorry, 9 or 8. I said 90 or 80. So we'll go with Charlize's number, but I think either of those would be fine. It's definitely not 5. Maybe 7. Yeah, you know, that's good. So we have 36 million is the range then. So we can read the range off of our graph as well. It says to start at 0. This to me is really optional, okay? If the numbers are all super big, it doesn't make sense to start at 0. Like, let's say we're measuring populations of these particular countries, 0 might be a really silly place to start. So while you can start at 0, it's not necessary. What is necessary is that you have equal intervals. So in other words, these are all 10 million square kilometers. They have to go up by a consistent amount. And does anyone know how many miles there are in a kilometer? Just to get a sense of how much this would be. Right, so there's actually 1.6 kilometers in 1 mile. And if you ever travel outside of the United States, everything is measured in the metric system. So all the signs, all the speed limits are all in kilometers per hour, not in miles per hour. You know, the money is different, so it's pretty cool. Now, a dot plot is what you guys created yesterday. That is what you put with the particular beats per minute when we measure that. So an example of a dot plot is on the back of your sheet. And the frequency you can easily read off a dot plot, because if you're looking at example 1, which is the most frequent pulse here?
68.
And what is the frequency of 68?
6.
1, 2, 3, 4, 5, 6. Okay, so our frequency of 68 is 6. And what I'd like you guys to do, and notice it says data points are pictured individually above a number line. So that means every dot is a person here. So this could be actually like a little drawing of you or your initials here, because this represents a person. So we have 2 people who had a pulse of 56, 1 person had a pulse of 92, and then all this stuff in between. Data points are pictured individually. Each dot represents a single observation, in this case a single person. Now, if you line these up well, okay, meaning like if it's 1 are all side by side, the 2s are all side by side, the heights of these are going to represent like a bar graph. So you can see 68 is the most frequent because it is the highest, all right? 72 is a little lower. And so if you line it up correctly, the height is the frequency. Okay, so this has a height of 6, this has a height of 5, so you can see the different frequencies. Okay, so what I'd like you guys to do on the sheet is answer the 4 questions. Once you are done, I'm going to have you compare to the person next to you, if you guys agree. Do you think a dot plot would be a good graph if we took the pulses of everyone in the school? Why not? Too many dots, correct. So imagine, everyone in the school with a pulse rate of, let's say, 68, it would just be super tedious. You'd have to put a dot for every single person who had that. So that's where you'd want to flip over to a bar graph, and maybe then you're going up by 10s or 25s, because we have 320 students to account for then, and you don't want to count 325 dots. Any questions on the questions that were given below? Yes, DJ.
I didn't really understand the last one.
So which pulse occurred most frequently? So in other words, which pulse did most people have in common? So what would you say if you think of that?
Probably 68.
Yeah. So the one that occurs the most frequency is the one that has the most people in that category. All right, so your assignment for tonight, you actually are going to need to do on a separate sheet of paper, because you need to construct a dot plot. And because we're working from worksheets, I'm going to have you guys actually hand this in tomorrow. So if you don't like ripping out of a notebook, it doesn't matter to me if you do, but if you don't like to, then I would do it on easily. So the reason you do need to do it on a separate sheet of paper is